turn down my symphony. I hope you've liked my symphony this evening. Oh my goodness, we got to turn that all the way down. Oh, symphony. Coming out of all speakers. Oh no, symphony. We're going to pause our Mozart. There we go. Maybe we'll get classy later. Who knows? Maybe we will. All right. What's up, Internet? Hello. This is Joey. You're watching the first episode of Everyone Loves Math live. I'm going to say we a lot, even though I'm going to use the royal we. We're going to do this show every school night, Monday through Thursday at 9 o'clock. If I get some followers, maybe we'll expand that and we'll go from 9 o'clock until question mark. We'll see. The goal of this show is just to be a call-in math tutoring show. I am happy to help anybody between grade 5 and calculus. And there's a couple ways you can ask questions. You'll see it down here below. There's 3 different ways to ask questions. One, you can do it in the Twitch chat. So I will say hello right now. Oh, cool. I misspelled hello. That's awesome. So I'm in the Twitch chat. If you have a math question that you want to post away. The other thing you can do is you can sign into everyonelovesmath.com. You see it crawling right, everyonelovesmath.com. So if you go to everyonelovesmath.com and sign in, you can ask a question on the message boards there. Totally free to sign up. I also have the Everyone Loves Math hotline, and it's showing right there. It's 727-341-6464. So you can call or text or send a photo or send a video. And if it passes the muster, we'll do it either on tonight's show or we'll do it on tomorrow's show. So all kinds of ways to get your questions answered. Before we get to the math, I should also give you a little tour, man. So Everyone Loves Math is my new website. Here it is. Behold it. Behold it. Everyonelovesmath.com. Take that, all of you people that have your .orgs and your .bizes. I got you at .com. Everyonelovesmath.com. If you go there, you'll see a link to this page. Don't click it or else your computer will just open up 2 of these. But the other thing that you should know is the message board link is up top, as well as a link for tutoring. So if you would like to have some private tutoring, we do kind of what we do during the show, except one-on-one, and we can take our time. You can follow the tutoring link and sign up for tutoring Monday through Thursday. So listen, we've got so much here ready to show you. We're just going to get to it. Let's do it. I'm into it. All right. So among my little toys, my little math toys, I've got myself a little whiteboard, and I'm still getting used to my little whiteboard, so you'll have to pardon me, you know. But what I did, just in case, you know, because I figured maybe a bunch of people aren't showing up with questions, I would just steal questions off the internet. And so that's precisely what I have done. What I did was I went to Reddit/homework help, and I found myself just a set of questions for us to talk about. And I am happy to stop doing them at any time. If we get a question come in on the hotline or a question come through chat, it's all good. But I figured, you know, it's probably best to do our math squats. Even if I don't have questions yet, we're going to do the practice because that's what is up. All right, y'all, let's get to it. So, again, these questions were just picked at random. If this show starts to take off, hopefully I'm going to get a bunch of your questions at random, and then we'll hit them up as we need to. All right, so y'all, let's get busy. How about this first problem? So what is the value of angles A and B? So one of the funny things that I've noticed not on Everyone Loves Math, the best website for math, but going on to the Reddit, is there's a bunch of teachers out there that either are asking trick questions or are not thinking about their questions. Because the answer to this problem technically is you don't know. You don't know. You don't have enough information to say A is this. Like if I say A is this or B is this, you don't have the information to do that. This can't be that kind of problem because you ain't got it. So what we can do is we're going to use like 2 geometry properties to answer this question as best as we can, because we can't give the best answer because we just don't have enough information. So what would we do? So there's actually two ways I could see us going. And I'm going to do the first way, and I ain't even going to lie. This is my favorite way. Because I can't remember anything. But I remember just a couple of geometry properties. And one being that the 120 degree, let me get my little colors up here. Look at these. The 120 degree and that angle has got to be 60 degrees. Those have to be 60 degrees. This angle and this angle actually both have to be 60 degrees. And if I really wanted to just get, look like a kiss up, I know what those angles are, no problem. There we go. The reason why I know that is that these are vertical angles. So if you want to look up your vertical angles, please look up vertical angles. That's one of the first things you learn in geometry. Doesn't require that much memorization. So now we can go and start thinking about angles A and B. Again, I'm not going to tell you what these are because I don't know. But I do know now one more piece of information about the triangle that they're in. We know that A, B, and 60 degrees are the three angles of a triangle. And again, I try not to remember anything, but there is one thing I do know, which is the angles in a triangle add up to 180 degrees. So what I do know is I do know that A plus B plus 60, because those are the three angles in that triangle, have to add up to 180 degrees. That's as good as we can go. And with that, we can subtract 60 on both sides. They're two variables, so this thing, we aren't going to be able to say what A is. But we can say this. And this is really the only extra piece of information that I would give my teacher based on what he or she gave me. All I can tell you about angles A and B is they must add up to 120. Because for A and B to add up to 120, pop on that extra 60, you got 180 degrees in a triangle. Now, your teacher may have been fishing for a different answer because you could actually get this answer in one step using the exterior. I'm just going to write it down on here. You can do it with the exterior angle theorem. So we can spend time talking about the exterior angle theorem. Hang on, I got to erase this because we got to be looking good here. We can't be misspelling stuff on my first episode. So if you want to look up the exterior angle theorem, oh, and I know I just wrote it over my dumb head, but I promise, here, I'm going to watch. I'm going to prove it. I'm going to prove to you I wrote it. Look at that. Oh. I'm going to move this guy. Nope, not that guy. Move this guy. Look at that. Exterior, that was a long walk for exterior angle theorem. But I promise you, there is something called the exterior angle theorem that if we wanted to do this in one step and your teacher was trying to get you to memorize these little, sorry for saying it, dumb theorems, then you could. But there's like 5 ideas about angles that if you fall back in algebra or geometry, you're going to be fine. All right. So let's make sure everybody can see this one. I just love these problems, man. Let's see. So again, these are all stolen from homework help. I hope to not have to steal my math problems for too much longer. All right. So what is the cost to drive from Atlanta to Orlando, a distance of 475 miles? If the cost of gasoline is $3.59 a gallon and the minivan gets 25 miles per gallon. So the reason why I love these problems is, man, this is called, I use something that I have known for like 40 years. No, not 40 years, 30 years, which I like to call funny forms of one. I like to call it that because when I learned geometry, my teacher taught me how to do it this way. And this same concept that we're about to do, it works in pre-algebra, it works in algebra, and then you roll up in chemistry, and you're going to see this again in chemistry when they call it stoichiometry, which, yeah, that's fun, man. I love that. All right, so how are we going to do this? Well, what we want to do is we want to start with what we know, and we know one thing. Well, we know a few things, but this is one piece of information that we do know. We need to go 475 miles. That's what we're going to do. And what we want to know, because we want to like convert this, what are they asking us for? Let's see, what is the cost? So the answer is going to be in dollars. So what we want to do is we want to go from miles to dollars. So let's take a look in this problem. In this problem, do I see a way of going from miles to dollars? Well, no. I see dollars and gallons, and then I see miles and gallons. But I don't see dollars and miles like mwah, like touching like that. So what we're going to do is we're going to set up a little chain using some funny forms of one. Stuff is going to magically cancel, and then we're going to have our answer. So let's work into this. And by the way, if you want to see this more, just ask. Pop in the chat. We can spend, man, I can spend an hour talking about any of this stuff. You know why? Because I love math. All right, so we're going to multiply this by actually two funny forms of one, because we're going to have two links in this chain. Now, how do I know there's two links in this chain? Because I've been doing this for a while. How would you know? You play with it. You just play with it and see. So here's the story. We want to end up with dollars from miles. And what we're going to do is we're going to multiply 475 by a couple of things, but we've got to fall back on this idea of funny forms of one. So if you multiply 475 by 1, you're not going to change what that number is. And so I could, like, for example, if I wanted to completely waste everybody's time, let's talk about it, wasting time. I could do that, right? I could do 45 times 1 over 1 times 1 over 1, and that would just be 475. It would also be extremely boring because that doesn't do anything. These are fractions that equal 1, but they're really boring fractions that equal 1. Let's do a neater one. So let me think here. I would love to put miles on the bottom because I know where I'm going. And I can't go to dollars, but I can go to gallons. So do I know something about miles and gallons? I absolutely do. Where is it? Over here, the 25 miles per gallon. So what does that mean? 25 miles gives us 1 gallon. All right, now let me go back to what I said. Funny forms of one. This right here, I'm going to use my little highlighter. Look at, see, I told you I got these toys. So that fraction, 1 gallon over 25 miles, that is a funny form of one. How do we know? Because the minivan gets 25 miles to the gallon. So 25 miles and 1 gallon are the same in the world of this minivan. Therefore, we just multiplied 475 by a funny form of one. What else did that do? Well, it did something really cool. Whenever we're multiplying with fractions, we can cancel if we see something same top and bottom, numerator, denominator, and I do. I see miles now in the top and the bottom. Now we know miles isn't a number, and what I just did is kind of theoretical, but we're in a math class, dude. Everything's theoretical. Let's go. All right, so if I stop now, look at the left side. The only unit that I have is gallons. That's the only thing left over. So if I stop now, that would tell me how many gallons I need to go to Atlanta to Orlando. But I don't want gallons. In fact, let's go back here. I want gallons. Oh my goodness. Boom. Man, I want this to be so pretty. Oh, screwed that up. That looks beautiful, right? That says gallons. So I want to go from gallons to dollars. If I can do that, then I will have connected the chain from miles all the way to dollars. And to do that, I'm going to use this right there. Boom. Gasoline is $3.59 a gallon. So $3.59 is the same as 1 gallon. And since the numerator and denominator are the same, that's another funny form of one. What's that allow me to do? I can now cancel out those gallons, and the only unit that's going to be left is dollars. So now it's just on us to multiply this out. We got to multiply 475 by 359 and divide by 25. I'll use my $1,000 calculator. I love it. Dude, I should put up the Mozart for this. What am I doing? If I'm using the calculator. Oh, Mozart didn't even want to stick around for the math. We gotta talk to him. I hope you like my symphony. Took me till about 6 o'clock today to realize that I had no music for this stream. All right, so I did 475 times 3.59 divided by 25, and I get 68. Oh, I'm still using that weird highlighter. All right, $68.21. Now, of course, like with money, we don't put the units at the end. I can't believe I'm just obsessed with these colors. So like with money, we don't put the units at the end. So like if we wanted to make this look like something humans would read, we would say like that. All right. We have now just effectively converted from miles to dollars using funny forms of one in a chain. How fun. That was great. All right. Here we go. Next problem. Little algebra 1. Little bit of algebra 1. You love algebra 1. So how many distinct zeros does the function have? So we're going to do this in a couple of different ways because I know that a lot of algebra students are learning this right now because it is coming up. So one way we're going to do it is we're just going to define the word zeros. So let's do that. Let's talk about what a zero is because that's what it is asking for. Oh, I can't highlight on there. All right, so let's talk about zeros. So what are zeros? Zeros are values of x that make, that make f of x equals 0. All right. Ooh, my logo. I gotta move my logo, huh? Boo, 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 boo. Do, 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 do. All right, let's move stuff so y'all can see it. How about that? Do, 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 do. There we go. And that little guy. Oh, look at all those little lines. They gotta go. All right, boom, baby. All right, so zeros are values of x that make the function 0. That's really all we got to go for that. And if you know what you're looking for, this problem actually doesn't require much math at all because I can tell you what's going to make this thing 0. So let's go ahead and get ready to put our answer. And like, sorry for picking easy problems, but it's my show. And I'm going to pick easy problems. You want harder problems? You pick them. Everyonelovesmath.com. All right, so let's talk. What are the things that make f of x 0? Well, here's what you need to know. And this is the secret that makes this really easy. F of x, I mean, if we wanted to be like nerds and stuff, which we aren't, we're completely, absolutely cool kids. But if we wanted to be nerds, you know, we could take this thing like super far, but let's make it easy, man. This thing is a multiplication problem. That's what f of x is. Look at it. Look at f of x right there. F of x is a multiplication problem. It's a bunch of stuff multiplied together. And so when I'm asking, or when your teacher's asking, when does f of x equal 0? The secret to this is when does a multiplication problem equal 0? Whenever you're multiplying and the answer is 0, what do you know about the stuff you just multiplied? You know, one of the things has to be 0. The only way that a multiplication problem comes out to be 0 is if you got a 0 in there. So check it out. I'm going to look right here. Highlight, and we'll go back to yellow. See that x hanging out right there? If that x was 0, then the whole function would be 0. Because it would be 0 times this, times that, times that. Who cares? 0 times a bunch of stuff is 0. But that's not the only way to get a 0 in the multiplication problem. Look at the next factor. The next factor, I'll just move that, is x minus 3. So you got to ask yourself, what makes x minus 3 0? It's a one-word answer. 3. If x is 3, then this middle guy right there, that middle guy comes out to be 0. And if this middle guy right here is 0, then we've got a multiplication problem that has a 0 in it. So f of x would be 0. All right, and then by that logic, we can pretty much wrap this up because we got 2 more zeros to find, although it's less about finding and more about pointing to them. What makes x plus 4 equal 0? Well, if x was negative 4, then it would, right? Because negative 4 plus 4 is 0. The last one, what makes x plus 5 0? Well, if x was negative 5, that would make x plus 5, negative 5 plus 5 equal to 0. So we've got our answers. And if I want to, you know, should I put my like pretty little, I'll put like a little bubble. Do y'all still do that? Y'all still put bubbles around your answers? Man, I do. I show my work and I put bubbles. So what we're going to do next is we're going to kind of blow this problem out a little bit. All right. And by that, we're going to do stuff that the teacher didn't ask. That's fine, man. You're with me. I got you. So what are we going to do? We're going to hit up Desmos. Let's go to Desmos and show you this. All right. So Desmos is my favorite graphing calculator. It's my favorite, desmos.com. It's my favorite calculator. And I've got it set up to do some graphing. And what I'm going to do is I'm going to type in that function, f of x equals x times x minus 3 times x plus 4 times x plus 5. All right, and we'll try to zoom out. This thing, look at this thing. This is a ugly function. I can tell you because, again, I've been doing this a long time. It kind of if you kind of stretch it out, it looks like a W. It kind of makes a W shape, but it's gnarly. In fact, if you're in Algebra 1, you don't have to deal with any of these, man, because, it gets gnarly. In Algebra 1, all you have to do is find the zeros. And guess what? You can totally check your work. I wouldn't dare say cheat, but you can check your work, and Desmos will tell you where the zeros are. Desmos says -5 is a 0. Yeah, that was on our list. -4. Remember, that was on our list. You can barely see it because the line is so steep there, but 0 and 3. Those were the 4 zeros that we found. How awesome is that? Answer? Very awesome. That was very awesome. All right, so that is our how we use Desmos, and I'm going to go back to that problem because I have a Algebra 2 version of that, or pre-calc version of that problem coming up next. So this is what it looks like in Algebra 1. If you're in Algebra 1, like you can maybe you listen to Mozart for the next few minutes. But we're going to move on to the Algebra 2 question. How about that one? And this person posted and they were in a panic. And they also said that they needed an answer right away. And I totally didn't. I didn't respond. So I feel bad. Hope this person did okay. All right. So this is the person, probably Algebra 2. And they want to find the number of positive real zeros, negative real zeros, imaginary zeros for these two functions listed. And I probably will only do one of them. I don't know. We'll see. We'll see how we feel. But what I like to do, I got my little pad of paper because I like to know what I'm up against. I'm going to go back to Desmos. Desmos isn't just good for algebra, man. How about Algebra 2? So I'm copying down this function. And we're going to put it in Desmos. It's going to be great. If you're working at home, maybe you can do it faster than me. Go to Desmos and put in that. That'd be really cool. All right, let's do it. Time to go to Desmos. All right. So now that we're in Desmos, that's still the problem from last time. So we're going to clear that out. And I'm just going to put in f of x. I'm going to be like -3x to the 5th plus 5x to the 4th plus 4x squared minus 8. So here's what I think is like really cool. They ask you about the zeros and they don't tell you a way that you have to find them. The best way to find these zeros is by graphing. And when I graph this thing, again, I want to zoom out to make sure I didn't miss any, but it looks like that's just going to keep going forever. So it's kind of one of those little whoop-de-whoops. And I can just click on the zeros. They asked us about the zeros. There's one, and there's one. So one thing that I wanted to use this as an excuse. If you are able to graph, then graph, okay? Now, all of this having been said, we do have a little bit of an issue. We do have an issue, you and I. The issue that we have, Algebra 2 student, is that this is a 5th degree polynomial. This is an x to the 5th, and an x to the 5th should have 5 zeros. This has 3. So what's up? Well, the other two are imaginary / complex. So if I was going to answer this question, and I can do it just by looking at it. This function has one negative Thank you. Thank you, Mozart. Man, it makes it really dramatic to have Mozart playing. It makes me feel like what we're doing here, but it's momentous. It feels momentous. That's what I want to say. All right, welcome back. Welcome back to Everyone Loves Math, ELM Live. Hope everybody's having a great night. I'm having a good night. I'm here with you. What's up? All right, so let's go back to where we were. All right, man, that's a pretty tiny little problem there. So let's make this a little bigger, shall we? Let's make this a little bigger. Where are we at? Do 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 do. Well, that's one way to make it bigger. Here we go. So the person online asked about question number 7. And I figured, this would be a good one to look at. A little geometry. Loosen up. Do some math squats on geometry. Happy to do it. So if we are looking at this thing, all right, let's take a peek. Here's a quadrilateral inscribed inside of a circle. Jada says it's a square. The quadrilateral, I assume. Jada says it's square because folding it along the horizontal dashed line and then the vertical dashed line gives 4 congruent sides. Do you agree with Jada? Well, Jada, yes and no. Yes and no. The answer to this question would be yes and no. But nobody ever wants yes and no. So what they want is kind of like a little informal proof. So let's do a little informal proof. It's the P word. Don't be scared of it. How about this? I'm going to call that R. That's an R because it's the radius of the circle. It also happens to be not a side of the square, not even a diagonal of the square, like half of the diagonal of a square. Because this is a radius as well. Those are both two little radii, if you want to, This is a little radius and that's a little radius. So what Jada was saying was we don't have 4 congruent sides of the square. We have like 4 half diagonals. Now, again, there's going to be 2 ways you go here. You either bust out the million different proofs about diagonals of a square and all this stuff, or you fall back to the same kind of like 3 things that I always fall back on. So here's what we need. I'm going to call, I'm going to put it in blue. What we really want are these sides. We want to show that these sides are all congruent. That's what we want to show. Now, I don't know that they're congruent, so I kind of have to like not call them all S. That would be bad because I don't know that they're all the same. So I have to give them like different letters or something. So we could be like super creative, but what if, man, it's 9:30. How about side 1, side 2, side 3, and side 4? All right, and when we talk about sides, we're talking about that square. All right, we're talking about the sides of the square because a circle doesn't have sides. We're all good with that. Okay. So we could do just like a quick little proof, right? So like take a look at the top left angle. Take the top left angle, right? So the top left angle, if you look, we know 2 of the sides and the angle between them, right? We know that R is this side. We know that there's a right angle there, and then R is this side of the triangle. We actually have kind of a lot of information about that. So what do we know? Well, that tells us, am I actually going to be able to erase this? I've probably created a huge issue for myself right now. All right, we're going to erase this. I can't, guys. I can't. The demon's coming for me. We're going to relabel it. Don't let the demon come for y'all. All right, how about that? So here's what we know. I'm not going to highlight it now. The top right triangle has 3 sides, and we know that 2 of them are R's. We know that the angle in between is a 90 degree. Look at the top left of the triangles. 2 sides we know those lengths. They're also R. And the angle in between has to be 90 degrees because they intersect at right angles. So what we're really looking here is we're really looking for these 4 triangles. So the 4 right triangles are congruent. That's our geometry word for equal. The 4 right triangles are congruent. And then S1, S2, S3, and S4. So all four of those sides, S1, 2, 3, and 4, are the third side of their triangle. So they're all corresponding. And then we evoke something that I really do think I first heard my best friend say 25 years ago, which is CPCTC. Do your best friends talk about math? Mine do. Corresponding parts, that's the CP, of congruent triangles are congruent. So what does that mean? S1, S2, S3, and S4, they're all playing the same role in their own little triangle. All those triangles are congruent. So S1, S2, S3, and S4, they're all congruent. S1, we could be like, let's use the fancy little congruent. How about that, huh? Use that fancy symbol. Impress people using that symbol. So this tells us that the four sides, S1, S2, S3, S4, are all congruent. We know that the diagonals intersect in a right angle. So therefore, we have a square. So the real answer for Jada is like, yo, Jada, it's a longer walk. It's a longer walk than you thought it was going to be, Jada. All right, let's look at a problem here. I want to do this problem just because I have I came across this problem and I probably should have looked it up. So this was asked online in Reddit homework help, and I'm just pilfering Reddit's homework help right now. And I don't know what language this was in, but I find this wild because whoever gave this problem gave it in two different languages if you look at it. And I just think that's really cool to have like a math class that's being taught in two different languages. All right, so thankfully one of those languages is English, so I can read it. It says table 1 shows the number of people in a state that have received the COVID-19 vaccine. So we see 3.36 million, 3.36 times 10 to the 6th. We have 3.36 million people, and that represents 69.3% of the population. So then it says, calculate the remaining people in the state that need to be vaccinated to achieve herd immunity target, which is 80% of the population being vaccinated. Wow, what a cool problem. What a neat problem. So let's play with this for a little bit because there's a bunch of stuff going on here that we don't know. And so we're going to play around with it. The first thing that we don't know is we don't know the size of the population. It just said, about 69% are infected, and it gave us a number, but it doesn't tell us the total. So the first thing we need to do is figure out the total. And here's what I know. I know that the part out of the total is the percent. So the part of the people that have received the vaccine, so that's 3.36 times 10 to the 6, out of however many there are, so we'll call that the total, equals 69.3%, 0.693. So we know that. Cool. So if we multiply both sides by the total and divide both sides by 0.693, we end up with this. We end up with the total is 3.36 times 10 to the 6th divided by 0.693. Whatever that is, that's the total. Okay, so let's get out our trusty calculators. And I'm just going to do the 3.36 part. That's what I'm going to do. I'm going to be like 3.36 divided by 0.693. And that comes out to 5. I'm going to do 2 decimal places. So 5.26. And then times 10 to the 6th. So that's the total number of people that are in whatever population this is, okay? The number of people in a state. So we can now figure out what 80% would look like, right? So what would 80% look like? We would say a number out of this total, 5.26 times 10 to the 6th would have to equal 80%. So this equation will tell us how many people we need to have vaccinated in order. Can I scroll on this? I think I can scroll on this. Oh yeah. All right. So this equation will tell us how many people need to be vaccinated in order for the vaccination to be the vaccination rate to be 80%. So all we have to do here is multiply both sides by 5.26 blah blah blah, and we'll get, you know me and my colors, x equals 5.26 times 10 to the 6 times 0.80. Right? We just multiplied that on both sides, just treating it like it's a number. And now we're going to clean this up a little. So I'm going to multiply the little number part. We'll leave the 10 to the 6th. But let's clean up the 5.26 times 0.8. And that comes out to 4.21 times 10 to the 6th. So that's how many people need to be vaccinated to reach 80%. Now, that's not what they asked, though. They asked how many more people would need to be vaccinated. So here's what we got to do. We got to start with how many we have vaccinated and figure out how many do we need to add to get up there. So we got to go back to that 3.36 number. So I'm going to say 3.36 times 10 to the 6th plus what gives me 4.21 times 10 to the 6th. And so all we have to do to figure this out is subtract that 3.36 times 10 to the 6th on both sides. All right. Those will cancel and we'll be left with our answer. Remember, that's the answer is how many more people we need. So all we have to do is subtract. So let's look and subtract, huh? So what do we got? We got 4.21 minus 3.36, and that gives us 0.85 times 10 to the 6. All right, weird. Let's go back and look at our answers. Oh no, something weird's happening. Look at this. 0.85 in one of the answers. That's strange. So, either I got this wrong. I could blame the language, although it's also in English. Either I got this wrong, or maybe the multiple choice is a little funky. So let's see. We'll see if you can find, did I make a mistake and you could find it? So I figured out how many total people there were, and then we wanted to get up to that 4.21. That's the 80%. Then we subtracted. Y'all are going to have to tell me if I made a mistake, all right? Cool. All right. Boom. Let's see. Ooh, we got a question in the chat. What's up, chat? Business calculus, the same as regular old calculus 1. Is it? That's a great question. What's up? What's up, Flash? So, technically, if you want to, like, I can tell you the difference. You're going to learn a lot of the same stuff. The difference is, in calculus 1, you're going to learn, like, the math reason why it's true. And in business, you're not going to spend a lot of time on why it's true. You're going to spend it on business-oriented word problems. I mean, that's really, like, calculus is just an excuse to do the coolest word problems. And so business calculus, all the word problems are going to be business. There's going to be less of the theory. In math, in the like mathy math calculus 1, there's still going to be word problems. Don't worry about that. There'll be word problems, but there'll also be, you'll be responsible for some of the additional theory. So if you're looking to take a calculus class and you don't have to take regular old like engineering calculus 1, and you want to take the business calc, go for it. Check with your advisor, but I say go for it. All right. Thanks for asking a question. See. Okay. Next up. Oh, here we go. We're just going to do I think we're going to do 2 more problems and sign off for the night. All right. So here's a problem that came up, and I saw this problem online. I need to make this bigger, don't I? I'm going to make this bigger. Check me out, man. Let's make it bigger. Man, touch it. There we go. Oh, there we go. So I saw this problem online, and the person that kind of phrased it in a way that I thought was funny. They were like, I know how to do this except that 2x. That's what they said. I'm like, I know how to do this, except that 2x that's in there. So this is where you need to be mathematically stubborn. So what I would say is don't worry about the 2x. You got to fall back on what you know. And we've actually talked about this. I think, gosh, it was the first problem we did. So what we're looking at here is two vertical angles. This is 143 degrees, which means its vertical angle, that thing that I just put in yellow, that has got to be 143 degrees as well, because they're vertical angles. I'm going to write that again. These are vertical angles. If you are a geometry student, you don't know what those are. Tutoring on my website. Let's go. Let's go. All right, so these are vertical angles. Vertical angles mean they're the same. And what that means is that top angle has to be 143. Well, what is that top angle? It's x plus 17 plus 2x. Right? That's what that top angle is. It's in three pieces, but we know all three pieces. Boom, baby. And we just solved that equation. Now, this is a two-step equation. If you're in geometry, should be able to kind of take care of a two-step equation. We clean it up a little, right? We see an x and a 2x, so we do the 3x plus 17 equals 143. And now we need to, do that thing where we subtract 17 on both sides. All right, fun. I like subtracting 17 on both sides. What do you get? Over here, those cancel out. We get 3x. Over on the right side, 143 minus 17. After 9 o'clock, I don't tend to do mental math. So I'm going to do it on my... Look, I have a degree in math, and I just did it on my calculator, okay? It's 126. Y'all leave me alone. All right, so now we just need to say 3 times what is 126? That's not one of the ones I got memorized. We got to divide by 3 to figure out what x is. So x is 126 divided by 3. Again, I'm going to use... Is it bad that I'm using my calculator? It's like 9:45 at night. Who does mental math at night? Even I don't do it. So x is 42. Boom, baby. Let's go back up and make sure we actually answered that question. Yeah, I forgot to put the question in there. They want to know what x is. So we just answered the question. X is 42. So might as well write it in. This is 42. This is 2x. So it must be 84. Right? 2 times 42. Boom, baby. Boom. All right, that problem's wrapped up. A lot easier than that COVID problem. Man, I'm going to be thinking about that when I go to sleep tonight, that COVID problem. Just kidding. I'm not going to sleep until I solve it. Okay, so now let's look at this problem. In this problem, they want us to find y, and I'm just going to go ahead and make this our last problem of the night. It's been great to be with y'all. Happy Wednesday night. Let's handle this bad boy. So what do we got here? Well, if you look at this, right, the key to this problem is that right here. Now, this is another place when there are like more complicated theorems to use, but I don't memorize them. I don't know what they are. Here's what I do know, though. What I do know is that these two triangles share an angle and have an angle in common, right? They have the same angle, that little 3 marked angle, and they have a side in common. And so what I know is, just based on that, these two angles are proportional. So I can't really write it because they didn't give these triangles names, but they're proportional. And if two triangles, this is what I can write. If two triangles are proportional, actually, I shouldn't say proportional. Let's say the official word, similar. So if two triangles are similar, then their corresponding sides are proportional. That I can't say. The sides are proportional. All right. So what does it mean for the corresponding sides to be proportional? Well, as long as we have corresponding sides, we can make fraction equations. I'll sound like an old man. We can make fraction equations till the cows come home. So what do I mean by that? Well, let's see. If we look up here, boom, 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 34 and 51. Those are both the sides that are opposite the angle, that congruent angle, those sides are proportional. That's what we know. Look at these two, that 40 and that y. Those are the two sides that are adjacent to that little 3 dingy angle. And because they're both the adjacent one, they are corresponding. They're playing the same role, just in a different triangle. And so what I mean by like fraction, I mean like we can do fractions out the wazoo. Check this out. I can say this. I can say 34 out of 40. That must be the same proportion as 51 out of y. These are proportional. I could also say, I could say something like this. 34 compares to 51, just like 40 compares to y. I could actually get this problem right by solving either of those problems, but I'm not. I'm not going to solve either of those equations, so I'm going to set my life up to be easy. Because why would I invent an equation